Let's prove this equation. Sine alpha plus beta is equal to sine alpha cos beta plus cos alpha sine beta. This is another trigonometric identity that we can write, from which we are going to apply this many number of times. Even in physics, we have applications of this identity at many places. So how do we derive this? This is very simple. Try to understand the derivations of every trigonometric identity. Every equation that we write is based on a mathematical logic. We need to understand the logic behind it. We need to practice these equations, derivations of these equations. Okay? In order to get expertise in trigonometry, we need to practice the derivations of these identities, the behavior of sine theta, cos theta, how to draw the graphs. All these things you should keep practicing. Alright. Now, moving ahead, so what I am going to do is, I am going to draw two right-angled triangles. This is one right-angled triangle. I will draw one more right-angled triangle here. So we have two right-angled triangles. Let me call this point O. This is P. This point is Q, this vertex. This is R. This angle is alpha. And this angle is beta. We are going to derive this equation. We want sine alpha plus beta. So drop a perpendicular from R on to OP. And from point Q, look at this horizontal line drawn from point Q. Let's call this point, this intersection point, with the name OPQR. Next comes S. This is P. Alright. Look at OP. OP is horizontal. This dotted line is also horizontal. These two are two parallel lines. Look at this line OQ. OQ is making an angle alpha with this horizontal line. So it should be making same angle alpha with the other horizontal line, this dotted line also. Since this angle is alpha, this angle is also alpha. Look at the right-angled triangle OQR. In the right-angled triangle OQR, this angle is 90 degrees. Look at this angle is 90 degrees. Since that angle is 90 degrees, total angle is 90 degrees, but on one side of the dotted line it is alpha. So on the other side, angle should be how much? 90 degrees minus alpha. This angle is how much? 90 degrees minus alpha. Look at this right-angled triangle. Which right-angled triangle? QSR. Look at the right-angled triangle QSR. Since this angle is 90 degrees minus alpha, this angle should be equal to alpha. Angle R is equal to alpha. You can see three right-angled triangles here. we are going to make use of three right angled triangles. One is OPQ, right angled triangle. The second right angled triangle is OQR. The third right angled triangle is QSR. So triangle OPQ, triangle OPQ, triangle OQR and triangle QSR are the right angled triangles that we are going to make use of. Triangle OPQ, triangle OQR, triangle QSR. These are the right angled triangles that we are going to make use of to find, to derive this expression. Now look at triangle OTR, one more right angled triangle. We'll use one more right angled triangle here, triangle OTR. Look at right angled triangle OTR. So we'll start with this right angled triangle OTR. In right angled triangle OTR, we can write sine alpha plus beta. In right angled triangle OTR, the total angle is alpha plus beta. That's the total angle. So sine alpha plus beta is equal to opposite side divided by hypotenuse. So sine alpha plus beta is equal to TR divided by OR. TR can be written as TS plus SR. Look at the figure. The straight line length TR is equal to TS plus SR. So I write sine alpha plus beta is equal to TS plus SR by OR. Look at the figure, TS is equal to PQ. So I can write this as PQ plus SR by OR, because TS is equal to PQ. These two lines' lengths are equal. So splitting the right hand side term, we will get sine alpha plus beta is equal to PQ by OR plus SR by OR. PQ by OR plus SR divided by OR. Now, here what we are going to do is, we are going to multiply in the numerator and also in the denominator with one of these sides in the right angled triangles. Multiply this ratio with OQ and multiply this ratio here with QR. We will get PQ by OR. We are multiplying with OQ in the numerator and in the denominator to the first term, and in the second term multiply with QR in the numerator and also in the denominator. Look at the figure, rearrange the terms here. This can be written as PQ by OQ into OQ by OR, and this equation can be written as SR divided by QR into QR divided by OR. Alright, look at the figure, PQ by OQ. PQ by OQ is in the right angled triangle OPQ. Look at the right angled triangle OPQ. PQ divided by OQ, that is opposite side to hypotenuse ratio, which is sine alpha. This is equal to sine alpha. This ratio is equal to sine alpha. PQ is opposite side of alpha and OQ is hypotenuse in this right angled triangle OPQ. Similarly, OQ divided by OR. Look at the right angled triangle OQR now. In right angled triangle OQR, OQ is adjacent side of beta, OR is hypotenuse. So we can write this as cos beta adjacent side divided by hypotenuse. Next, plus, look at the right angled triangle QSR. In right angled triangle QSR, this right angled triangle. In right angled triangle QSR, SR is adjacent side of alpha and QR is hypotenuse. So this has to be cos alpha adjacent side by hypotenuse. Next, look at the right angled triangle OQR. OQR. In this right angled triangle, QR is the opposite side of angle beta and OR is the hypotenuse. So QR by OR is sine beta. So hence we proved that sine alpha plus beta is equal to sine alpha into cos beta plus cos beta into sine alpha. One more trigonometric identity. I am not writing or explaining the proof here. I leave that to you. One more trigonometric identity, which is cos alpha plus beta, can also be proved from the same picture. So cos alpha plus beta is equal to cos alpha into cos beta minus sine alpha into sine beta. This is second trigonometric identity that can be proved in the same procedure. Okay, taking two right angled triangles like this and proceeding in the same manner, you should be able to derive this expression. So I am leaving that to you. So these two are two very important identities of trigonometry. Moving ahead, let's write few more identities. Sine 2 theta. How do we calculate sine 2 theta? We are going to make use of this identity that we already written here. Sine alpha plus beta is equal to sine alpha cos beta plus cos alpha sine beta. We are going to make use of this. And similarly, we will also write cos 2 theta later. So we will use this cos alpha plus beta is equal to cos alpha into cos beta minus sine alpha into sine beta. These two identities we are going to use here. Sine 2 theta can be written as sine theta plus theta. Use this. Alpha is equal to theta. Beta is also equal to theta. So if you use that identity here, it is like sine alpha plus beta. So you have theta in place of alpha and also theta in place of beta. So this is sine alpha into cos beta plus cos alpha into sine beta. When you simplify this, look at the left, these two terms, sine theta cos theta. This is also sine theta into cos theta. So what are we getting? 2 sine theta cos theta. So sine 2 theta is equal to 2 sine theta cos theta is another trigonometric identity that we will be using. Next, similarly, cos 2 theta is equal to cos theta plus theta. Alpha is equal to theta, beta is also equal to theta. Cos theta plus theta is, applying that here, cos theta into cos theta minus sin theta into sin theta. Cos alpha into cos beta minus sin alpha into sin beta, which is equal to cos theta whole square minus sin theta whole square, which can be written as cos square theta minus sin square theta. So hence we got this relation, cos 2 theta is equal to cos square theta minus sin square theta. This is another identity, trigonometric identity, which can also be written using this trigonometric identity, sin square theta plus cos square theta is equal to 1. This equation can also be written in terms of cos theta or in terms of sin theta. Let's also write it. So first, I am going to substitute sin square theta is equal to 1 minus cos square theta from here in this. If I do that, I will get cos 2 theta is equal to cos square theta minus 1 minus cos square theta. So cos 2 theta is equal to 2 cos square theta minus 1. Similarly, we can also write cos square theta is equal to 1 minus sin square theta and substitute it here. If you do that, you will get cos theta is equal to 1 minus sin square theta. In place of cos square theta, I am writing 1 minus sin square theta minus sin square theta. When you simplify, you will get 1 minus 2 sin square theta. This is another way of writing cos 2 theta. You can write cos 2 theta completely in terms of sin theta or completely in terms of cos theta. Okay, so these are the most of the trigonometric identities that we make use of in physics. This is almost all the trigonometry that we use in physics. So understanding these identities, understanding how to derive these identities is very important, not mugging up these identities. You don't have to mug them up, you don't have to memorize them, you have to understand them.